The Datastream area is the area where you can assign CANBUS outputs and inputs to be received into the ECU. This is generally used heavily with our plug-and-play kits and needs to be tread carefully in these areas. The point of this video is to explain about each section and how these areas can be manipulated on a generic setup and on a plug-in kit. So in the Datastream area, you've first of all got the option to be able to set the speed for each CANBUS. Now, on most of our cars and kits, the S6 will be fixed at 1 megabit, okay, which is sent out on the generic versions. If it's in a plug-and-play version, it will be 1.3, and that's talking to our vehicle interface module boards. The CANBUS 2 and CANBUS 3, which is found on the S7, S8 and S12 and extra CANBUSes, these you can actually set and adjust the speeds here. They're blue items, so they do need to be flashed in order to be saved. The transmit area of the generic CAN setup is basically the area where you can assign which items you want sending out on the CAN bus, which bus they're sent on, and which definable identifier. What this has done is this has actually broke down into 4 stages. The first stage is the transmit bus. So a good port of call to think about is to say that frames 1 to 20 are used generally for plug-and-play kits for key items which are needed to go out to our external CAN bridges or interface boards which are used in kits. So it's best to leave frames 1 to 20 alone and assigned on CAN 1 on most ECUs. If you've just got a generic ECU, then it doesn't matter and you can define that to as you want. But for a plug-and-play kit, leave 1 to 20 alone. Now 21 to 40 you can actually define and do as you wish. So for this particular setup we're going to actually say that we've got a dash connected to our CANBUS 2 on this ECU, and we're going to set up so that frames 21 to 40 are used for CAN 2. Then what we're going to do is we're going to set the identifier. Now the generic identifier which is used by most dashes to know for the Syvecs range is actually on the 600 range, from 600 to 613. So what we're going to actually do is we can actually just copy this item here all the way to 613 and actually paste that into here. So it's exactly the same on the other frames. And that's not a problem because that's going on the second bus, so there won't be any conflicts or clashes. Then the frequency allows you to set the data speed for each frame. So this is the update rate of how often that frame is sent. So for an external dash, a good thing to look at, unless you want the data getting out really fast, is to basically set that all at say 10 Hertz. Okay. Then what you then got is your content. Now, as I said already, the frame 1 to 20 content is generally used for a plug-and-play kit. If you've got a generic ECU, don't worry. But what we want to do is actually fill in the 21 to 40 with our custom data that's going to be going to the dash. And we can actually provide you with an example cal for this from support if you want to email us. And I'll also get that put on the forum so it's easy to do. But for this particular instance, what we're going to do is actually just going to copy the same frames into the items down here. It'll be a good starting point because they're generally in the right setup already, and then we can manipulate them after to suit our dash setup. The generic CAN receive area enables users to be able to get CAN data in from external modules. This is separated into 2 sections, receive A and receive B. First of all, it's worth mentioning that the CANBUS structure is 11-bit with identifiers, and the CANBUS speed for each area can be set as already talked about in the CAN 1, 2, 3 bus speeds. Then you need to assign the receive bus that you're looking at, so CAN 1, 2 or 3 again. And what you can do is you'll see here that the frames can be picked up based on each CANBUS. Now when you look at an 11-bit identifier and CANBUS frame, how it's structured, as you can see here from the KT8 example, basically is split into 4 separate sections of 16 bits. So if you had generally a normal CAN frame which has 8 bytes of an 11-bit identifier section, you can see that 2 of the bytes are joined together in order to make 16. So if you're receiving a generic receive B item, these are 8-bit items, and if you're receiving a generic CAN receive A item, these are 16. The KT8 sends in these items as 16-bit values as shown here, as you can see the corresponding bytes joined together. So what we're going to do is go over how to set up the generic CAN receive for actually receiving the KT8 frames. So what we've done is actually wired the KT8 to the CANBUS 2 on this particular S8. So the first thing that we need to do is actually go about setting up the enable. Now if you connect and already see that there are some items already set to yes in here, this will be most likely because you have a plug and play kit which uses the generic receive function to get external data in from an OEM's car's CAN bus. I recommend here that you highly do not touch this because this is vital in order to get the data in for the plug and play kit. The sections which are set as no though, you're actually free to be able to change to suit. So what we're going to do to keep it well away from the other receive items, we're actually going to change the frames here A25 and A29 to A32. So first of all, we're just going to do the first one, so A25 to A28. Now these numbers, what they differentiate to is the pin assignment of the frame slot, and I'll come back to that in a minute. So A25 to A28 we've now enabled. This is going to be now on the second CAN bus, and this is going to be using the identifiers which are preset in the KT8 EGT unit. So we can see here that frame ID, the first frame, comes in on 0xF6. So we can pop in here, enter, and put in here 0xF6, and we need to put a H at the end to basically state that it's in hexadecimal. After doing so, you'll see that the value is then presented in this section for A25 to N28. And we're going to do the same for the A29 to 32 to receive the other items from the KT8 unit. Now, once this is done, if you go down to the I/O configuration, you can then assign these XCAN items to a function part of the pin assignments. So as I've already done, I've already created two EGT items in the custom sensor naming, which there is a help video on this also, which I'll put a link to at the bottom, that allows you then to assign these XCAN items to EGT 1 and 2 and carry on if you wanted to go all the way up to 8. So, XCAN, and basically we've actually just used XCAN 25, and this will then be the first 2 bytes. XCAN receive A26 will then be the next 2 bytes. So to go over this again, X25 receive A is assigned to identifier F6, and these are on an A generic receive item, so they're 16-bit. So we look at the data sheet for the KT8 and see that byte 1 and 2 are assigned to bytes identifier F6, and they will come in as EGT1, so KT1. And then if you wanted to do that for the next ones, you could obviously carry on and do that in the section for the identifier F7, which would be A29. Once you've done this, these are blue items, so they need to be programmed. Now the scaling that comes from the KT8 will already be matched to what is needed inside of the ECU because it's a Syvecs based product. But if you're trying to get CANBUS data in from other external units which aren't Syvecs based, it's worth remembering these points. First of all, the data comes in a big endian format. They're 11-bit identifiers, and the scaling for each of these units can be found under the content of the transmit. When you're trying to send in, say, for example, an air temps reading on a 16-bit, you can actually see the format which is used at the top here, x divided by 10, and it shows you the range in which will be sent over. With items like that, it's probably better to use the B range of the generic receive, because a 16-bit is generally used for items that need more resolution. The rest of the Datastream section is set up as default templates for receiving CAN messages from other modules. You have the PDU CAN receive, GPS, and the Bosch M4, and many other systems which are already integrated into communicating with the ECU. We're going to look at a very simple one, which would be the GPS unit. So we're just going to connect a Syvecs 50Hz GPS unit to the S8, which we've got here. This same example goes for the S7, S8 and S12. The S6 Plus is different, and I'll go over that next. First of all, you select the receive bus in which the GPS unit is wired to, and make sure that the receive bus you're using is on the correct speed of bus that the GPS is connected. For example, if you're using CAN1, which I'm used in this example, it's set as 1 megabit. On the receive bus, we've got it assigned to CAN1. So on the Syvecs 50 Hz unit, there are two CANBUS speeds available. There's the 500 and the 1 megabit. So it's important to ensure that the CANBUS corresponds to what the CANBUS is on the ECU. Once I've set it up, so mine is actually connected onto CAN1, which is the 1 megabit bus, it's a simple case of enabling it to receive the AG50 and then programming the ECU. If the CAN bus has been received successfully, you will then see under device errors, no errors for CAN timeouts, and you'll see the data on the right hand side coming in for the lateral G for the accelerometer positions that are present inside of the GPS unit also. The GPS data will only come in, the speed is set at 360, and that's when the satellites have not been found. Currently I'm inside, so we have no satellite data available. With the S6 Plus, although there is a GPS option available in the Datastream sections, where this CAN bus on the S6 is used for the vehicle interfacing, the single CAN bus that comes out of the S6 control board, basically that means that we can't actually use the receive GPS option because the CAN bus is actually set in a slave mode, which is communicating with the interface board. In order to get the GPS working with the S6 Plus range or the S6i, you actually need to connect the GPS to the external vehicle interface bus. And what it will do then is it will then transmit that CAN bus data automatically into the ECU. After that, you then need to go to I/O configuration and slave link options and enable the Excel RX enable and gyro receive. After doing so, you will then find in the Datastream section, when looking at the item still for the GPS position, the data will still then be coming in correctly, even though you haven't got the receive GPS option there. This is a workaround in order to get the data in while the CAN bus has been fully populated with the vehicle interface.